So hello everyone, I'm Aurélie Baker, I'm the Big South France manager, and today I'm glad to welcome Aurélie Dehouck from IC. It's just a little word about this webinar. Since a few months we decided to highlight our alumni. So today we are talking about IC, incubated at the Big South France a few years ago. So Aurélie, I will let you the floor and explain what you are doing with IC.
Yes, thanks, Aurélie. Thanks again, and also thank you for proposing us to be on stage, if I can say, this afternoon, and share some of the issues we are dealing with in IC. So the title I've proposed for this meeting today is to investigate how artificial intelligence and Earth observation data can meet together environmental issues, in particular over coastal areas, which are the key topics we are investigating here in IC. So just a very few words about who we are. There you can see some of the main support and actors that have been supporting us from early stage. And early stage was typically this ESA Business Incubation Center, south of France. Aurélie Baker is a representative, and along with the French Space Agency, the CNES, and French governments, providing funds for innovation and satellite application development, BPI France and so on, and of course regional authorities, local authorities at Bordeaux. Here we are in Bordeaux City, who have provided support, in particular early stage at the beginning of this adventure with the IC company. Up. Okay, so moving on, some of the key issues I would like to put some focus on during this webinar. The first of one is the one dealing with coastal hazards. Behind coastal hazards is all the key stakes about coastal erosion, coastal flooding, beach and shoreline management and planning, to prepare and also to plan our coastal cities to facing these already existing hazards, but also prepare them to go towards the impact of climate change over the coastal areas. The second point I would like to put light on is about speaking and talking about coastal biodiversity and the way also Earth observation data and artificial intelligence methods together are providing information for the monitoring of natural landscapes over coastal regions. And then the third will be issues about coastal water quality and some examples of the same, how Earth observation supports industries, and I would say in particular harbor industries, ports, operations, and also the mitigation of the impacts of their activities over the coastal water quality and marine habitats. Okay, well, I will go through this first slide very shortly, very rapidly. Just a few. Many of you are probably from the downstream space application sector, but you all know that today we have a wealth of satellite data, Earth observation data coming from space that can be used in particular to address these coastal issues that we are speaking about. And in particular, focus is really done on the use of optical imagery from medium range to high resolution and very high resolution. You have some examples of this kind of satellite data. You all know, some you may know, And in particular, this data can be accessed from commercial platforms and service providers like Airbus, for instance, and also, of course, from the Copernicus Hub, Science Hub, where you can download Sentinel-2 and Sentinel-3 for what is of particular focus to get these added value products for coastal monitoring. Okay, what about coastal hazards? Maybe you may know, some of you, that my idea behind this webinar was to provide you with some insight of what are the news in our domain of activity in coastal and monitoring, and especially in what kind of project and activities IC is involved into. So the first point I would like to highlight is that there's many stakeholders, at local, regional, national, but also space agencies that are willing to put some light and focus about the topics of coastal hazards. And this is particularly the case of the European Space Agency, and also some initiative we have in France with the CNES, the French Space Agency, that have provided some framework where to continue developing, prototyping new services dealing with these coastal hazards. And one of these services is the one that can target the issue of coastal erosion. Maybe you may know that there's ESA, the European Space Agency, has been funded these last 2 years, a major program dealing with coastal erosion from space. And this is what this slide is showing. This is typically the extent of investigation of IC along with our partners along Europe, that you may find some details on the bottom of the screen. This major coastal erosion program that has been launched 2 years ago, 2019, with the willingness to have some kind of coastal erosion service being operative at the end of the program along and across Europe coastlines, and also maybe going global, international, so providing support using Earth observation with added value products for coastal erosion monitoring and management. And typically this program, Space for Shore, that is led by IC with our partners, has involved stakeholders, final end users, I would say, people managing coastlines, shorelines, beaches, and managing, but also protecting marine protected areas, also natural parks and so on. All these guys have been contributing to this program by co-developing together, co-prototyping what could be in the coming months, coming years, a European coastal erosion service for the monitoring of our shorelines along Europe. So there you have some highlights of the pilot countries that have been selected: Portugal, France, Germany, Poland in some extent. This is more a country where a partner came from, Romania, and South Europe with Greece. Over these 5-6 countries, it's about 2,000 kilometers of shoreline that have been investigating over the 25 past years, thanks to satellite data and satellite imagery, to get this evolution, this assessment of coastal erosion processes and coastal change occurring over our coastal regions. So there in front of you, you have some an example of this kind of information that can be derived from the satellite imagery, even if we're working with high resolution decametric imagery like SPOT or Sentinel-2. The project has found some of the significant results was that even using decametric results, when you're combining several individual images over one region over a short period of time, you can derive very accurate location of the shoreline indicators and the indicators, the proxies of coastal erosions that are typically surveyed on the field. And this is quite an interesting results, because in our mind in IC, when we started with the project, we were not sure of being able to derive with enough accuracy the accuracy sought from the final line users. So to have these satellite derived products that would provide enough added value by being accurate. And finally, this is the case even using decametric data, but you know the high frequency and revisit time of these individual images, then you can sum up them, you can average them, you can extract the maximum envelope of the shoreline extent and so on. And this is matching quite efficiently the field observations and the ground truths derived from the field. There you have another example, finally, of the kind of application dealing with these coastal dynamics and coastal hazards issues. Here we are in French Guiana, so we're not really in continental Europe, if I can say, but more in the tropics and over the equatorial area at the other side of the Atlantic Ocean. And the same question has been tackled and by the French Guiana end users and stakeholders over there. Their shoreline and coastal erosion can be approximated and investigated by monitoring other kinds of geomorphological patterns. And what you can see on this animation, on this video, is that you have the envelope of the mud sandbanks that are developing on the shallow waters from the 10 first meters of depth from the shoreline, and over these coastal areas that is under the influence of the Amazon and rivers. There are really major changes in the development of these sandbanks, in their migrations along the coast, that are affecting the coastline and the shoreline and the coastal cities in French Guiana. And the stakeholders, people managing the coastal observatory in French Guiana, have required, expected this kind of products, which is showing the dynamics, the migration of the sandbanks, and could be linked with a better acknowledgement, finally, of the coastal erosion processes and better capacity to anticipate, finally, the future location 5 years, 10 years in front of us of the location of the sandbanks and mud banks, and then the coastal erosion issue for these short and mid-term perspectives. So this action has not been funded by the ESA Coastal Erosion Program, but by the Challenge Innovation Copernicus and by the Commission Européenne, the European Commission, and the Copernicus Program through an action led by CNES and Aerospace Valley. So if you want to know more about all these aspects about coastal erosion, coastal hazards, and how Earth observation can provide support in their everyday monitoring and long-term monitoring and the assessment and anticipation of the effects of coastal erosion, I encourage seriously. You can go and type on your computer spaceforshore.eu. This is the website of the program, the Coastal Erosion Program. You will find most of the results reached from the last 2 years, and you will know more about which areas have been investigated. You can also download the products which are available at the Eugenius platform if you're really interested in. And you will find also details about the algorithms and the methods that have been used to derive this kind of coastal erosion indicators. This range of indicators that you can see on the screen, and covering finally all the kind of geomorphological and kind of coastlines along Europe, from sandy beaches, coastal dunes, to tidal flats and coastal lagoons, and also to rocky shorelines with coastal cliffs. Okay, there, yeah, some more information. This is the first page of the website. You will find all the final meeting presentations about the project. Please visit the address if you're further interested about it. Now, biodiversity, because yes, I've put a quite interesting title about how artificial intelligence and Earth observation meet together to fill the to provide these added value products for coastal monitoring and thus biodiversity. So okay, now we're inside this issue. What you have behind you is the kind of conceptual, the big pictures about the methods that here in IC we are operating when dealing with biodiversity and landscape and vegetation mapping using Earth observations. So the heart of the process is using machine learning algorithms fed by, of course, temporal series of Earth observation data, typically high resolution Sentinel-2, very high resolution data like Pleiad data or SPOT, crossing this with the ground truth. So this is field observation of vegetation typically, and giving all these data sets, satellite with the ground truth, to run machine learning algorithms, typically random forest algorithms, that fit the best a predictive model that allow finally to get vegetation and natural habitat maps over even local, very tiny local areas of some squared kilometers of geographical extent, but also potentially over large areas like Natura 2000. You may know that in Europe we have European directives for environmental monitoring and environmental conservation. And when dealing with biodiversity, the main European directive is the one dealing with habitat, fauna, flora, evaluation and conservation. And you may know that in France or over Europe, there are thousands of protected areas belonging to the Natura 2000 networks. And typically these areas need to be investigated, monitored regularly on a 5-6 years basis. These 5-6 years in general are moving and shifting to 10 years because of these biodiversity managers often have restricted budgets to deal with this issue, but they are in need of regular information about the status, the health, the conservation of the population of vegetation, the ecosystems that are populating their areas of interest. And there, it has been found that crossing the satellite data, the satellite imagery with the ground truth is providing very, very accurate both in space. You have there some examples of the resolution of the kind of vegetation maps that can be derived from the satellite imagery. Of course, this is really linked to the resolution of the input images, so it can be metric, let's say. But also, this is really high resolution in terms of typology, in terms of the type of vegetation. So really, the vegetation and the ecosystems that are constituting the area of interest. And then we can see that these mechanisms, this procedure, this processor for providing vegetation biodiversity maps is really providing fine results about the kind and the types of vegetation communities that are really in link and coherent with what the biodiversity managers are expecting with regards to their maps of the environments and what they are expecting to have every couple of years to investigate the behavior and the trajectoire. I would say, what is the word in English? The trajectoire of the environments and the vegetation ecosystems. Why I'm talking about this is because this biodiversity issue is really a major issue right now. It has been, it still be, and it will be a major issue for the next decades, both in natural landscapes, but also in the cities and in the big cities. So this is really an interesting application where we can show how efficiently EHO, Earth observation data, and machine learning algorithms are providing efficient, accurate maps that are really coherent what the managers are expecting. What was interesting when targeting this application is that if I'm coming back, just a few words to say, the same ISA Business Incubation initiative has allowed us at the start of the foundation of our company some 6-7 years ago to focus on the coastal hazards. The same kind of initiatives funded by the French governments and associated with some stakeholders of French biodiversity has allowed us the same to have today an on-the-shelf product that is serving these issues of biodiversity monitoring and conservation, at least in France. But I know that we have some of our colleagues and competitors in other European countries that are also doing such kind of business in their domestic and home countries. So yeah, that's for sure a very interesting market with this kind of application for Earth observation. Okay, the last picture as another example of what can be done using very high resolution satellite observation. So this is not a satellite picture imagery, but an aerial view of on a tiny area of Bassin d'Arcachon in the southwest of France. This is a tidal lagoon where the sea is moving down, and you have major tidal flats all around the lagoon when the tide is low, when this is low tide, and when you have there in color from purple to yellow is the density of oysters lying on the seabed. And this is a really critical issue in Arcachon, like in other lagoons over the French Atlantic coast, where oyster farming activity is well developed and is really a business. This is the case in Arcachon. It's been decades, 10, 30, 40 years now, that natural and exotic, I would say, oysters are developing naturally over the seabed. And now it's almost covering 100% of the tidal flats over the lagoon. If there are some French people hearing at me at the moment, you may know that the Arcachon Lagoon has been protected as a marine park some years ago. And one of the main actions of this marine park is to rehabilitate these tidal flats by removing all the oysters and oyster seabeds over the tidal flats. And this have been, so they are in need of some monitoring tool, quite precise monitoring tool, to have regular updates of the way the oyster seabed is developing, but also on the way and to quantify the effectiveness of the actions the marine park and its partners are doing on the seabed to remove these natural oysters. And this is done, typically, we have developed and prototyped this mapping tool using both aerial surveys and deep learning at this case, together also with some ground truth or photo interpreted ground truth, to have these very efficient and very precise, accurate mapping tool, being able finally to provide this regular updating of the information required by the marine protected area. So this is another example of how machine learning and deep learning can be used with both satellite and aerial pictures to get very fine, detailed and accurate results about what is occurring over the coastal areas. Okay, last, about biodiversity, I would just like to have quite clear in mind what is the status, I would say, of the deployment of this biodiversity service in our country, in France. There you have the map of France, and you have some examples of the people that have already bought these Earth observation-based service for their biodiversity issues. And finally, in 2-3 years, from the end of 2018 and the end of our research and development program, BioCoast, finally, in 2-3 years, now we have about 20 references, that is 20 contracts, being all biodiversity managers, being marine protected areas governed by the French Biodiversity Agency. This is OFB. You have national reserves of biosphere, you have national parks, regional parks, you have also Natura 2000 managers, in particular in the southwest of France and the south of France. And very recently, we have also converted some major cities to get interesting in the added value of the satellite remote sensing products. And this is particularly the case here in Bordeaux, where inter-annual program of biodiversity monitoring has been recently signed with partners in Bordeaux, and also in Lorient in Brittany, where also new activities is starting this summer to provide Lorient City with a global atlas of biodiversity at the scale of the agglomeration. Okay, I hope everything is going well and everyone is still there. It's still there. Okay, the last and the third issue I would like to share some results and information with you is about coastal water quality. So, okay, coastal hazards, biodiversity, and then water quality. So we have the third big pillar of our activity in ERIC. So there in front of you, you have a picture. So, well, it seems to be a picture, but it's not exactly a picture. It's a map of sediment, suspended sediment matter in the water column. We called it turbidity. So this is the content in sediment in the water column that can be quite easily computed using satellite imagery. This is what we called ocean color applications. And you may know that using Sentinel-2, Sentinel-3 images, these images can be converted in several environmental parameters linked to the water column. This can be niche shore bathymetry, the water depth. It can be the content in sediment matters, and it can be the content in chlorophyll, for instance, of organic matter, and so on, and other derived proxies and parameters from the water. And in particular, turbidity, this is really an application where we have an ancient background in using satellite remote sensing for this topic. Turbidity is really a parameter of big interest because you may know that along rivers and estuaries, there are really considerable exchanges of waters and sediments that are moving from upstream, from the watershed to the sea. And in coastal areas, this may have some consequences over the quality of the coastal waters. Let's say in the first hundreds and kilometers from the coast, because there are very major exports of sediments from the rivers to the inlets. And then you have specific pictures and specific issues of turbid plume dynamics at the inlands, in between land and the sea, at the exit of the major estuaries. And these have really several issues, sanitary issues with regards to aquacultures. Like here, we are again in the southwest of France. This is Ile de Ré, close to La Rochelle. And in Ile de Ré, Ré Island, you have several oysters and mussel farming. So this content in sediment suspension in the water column can really affect aquaculture and shellfish farming. It can also affect bathing water quality, and it can affect the same marine habitat conservation, because where sediment suspension and turbidity is high, potentially they are less light for marine habitats like seagrass meadows or algal meadows, or and so on, or the corals if we are in tropical waters and environments. So just a focus, just a few words to say, because I see that the time is running. I was thinking it was interesting for you to have this kind of overview. So sorry, the slide is in French. But what can be done with this with satellite data crossed with mid-ocean data sets and databases? Just some insight that today we have quite interesting products. So they are still under development, but it's already used by some of the stakeholders, and in particular industrial stakeholders like ports that are having dredging activities. And these dredging activities are potentially providing overload in turbidity in the coastal waters, and can potentially affect some of the activities and the marine habitats we've talked just previously. So how we are using all of this today, you may know that from the satellite remote sensing, you can quite easily derived near real-time coastal water quality monitoring at every time. So you can monitor the estuaries, you can monitor the coastal areas, but you can also monitor the impacts of the dredging activities, for instance, that are occurring right now over the coastal areas. Okay, so this is the first point. When you're dealing and using the satellite archive, also you can provide assessment. This is the point one of the turbidity background, or the turbidity, natural turbidity levels that are observed every day using Sentinel-3 over large coastal areas, over the areas where the port will be having its activity, but also over the regional area. And you can also define and get some derived information about and provide support at initial stage for the environmental studies about the turbidity thresholds and the turbidity content there will be during the working operations later. And all this, you can also, number 3, provide support in the definition of the better strategy where to place in situ sensors for monitoring water quality and turbidity during the working and the operations and the dredging operations. So finally, you have 3 benefits: turbidity background and turbidity assessment, sediment behavior over the area of interest of the port, support for environmental monitoring with the in-situ deployments, and also support with the assessment of the turbidity thresholds. And what we've been working on since last year, we've been working on a more kind of turbidity forecast, like you can have turbidity meteo, turbidity weather of 3 days in front of us during the working operations. You can have information like this on the number at some particular location. Here we are in the South Mediterranean, French Mediterranean, at Port-la-Nouvelle. Port-la-Nouvelle is an operation, is an harbor that is expanding and is developing new infrastructures to welcome the wind farms in the coming years. So there are new quays, there are massive dredgings of tens or hundreds of tons, millions of tons of sediments that will be extracted from the area. And with this product, this turbidity forecast, at some special locations where there are specific ecological or aquaculture issues, you can have complementary information to get along with in-situ information. So new information, new locations of the expected turbidity that you will have at 3 days. And this is really helpful for the port managers that can really operate better their environmental monitoring and their dredging operations by knowing in advance the level of turbidity they will be naturally in the area, and so that they can adjust the working operations, let's say the following days, but preferring delaying some activities that are potentially harmful for the marine environment. So this is some work that has started last year with the support of ESA, in the kind with the Kickstart funding. These products we have started to put in on board on a marine platform. This one performed by our partner Cine. So this has been done first time this winter for Port-la-Nouvelle, and this is typically this application we are continuing developing this year and probably next year, that we have proposed for new funding to get this application more global, that could serve really global stakes around the world while being crossed and put toward this kind of marine platforms and marine infrastructures dealing with coastal monitoring. Okay, so this is one of the last examples I would like to show you today. We've talked about turbidity. You may know also that chlorophyll and the content of biological organic matter you can have in the water column is also something of importance, in particular when you're dealing with fish or fisheries or aquaculture or shellfish farming and so on. But also you may be aware that there are some harmful algal blooms occurring over the world. And typically this is also something that can be monitored using Earth observations and more ocean color algorithms to derive from the satellite data information about the concentration in some harmful algal constituents in the seawater. And this has also been done. You're not alone in Europe to perform this kind of application, but this is the occasion to say that the Copernicus Marine Service has been funding this application over the Baltic Sea, which is typically a major area where this kind of event, harmful algal blooms, is occurring. And today we have an application running over a website and a web system, but also over smartphones. And then you have an example of the app developed for this application. Okay, this was more or less what I wanted to show you today. Of course, there are some other examples of how machine learning, deep learning algorithms are helpful for other coastal issues. And maybe this is the last finished slide. There you have also all the stuff about automatic detection of specific objects over the satellite images. These kinds of algorithms really perform interestingly in detecting each of these event or if of each objects. And there we are in the French Caribbean in Martinique. And there's a contract running for the Coastal Tourism's agency in Martinique. And it has been done to automatically count the number of boats over the coastal areas to provide some statistics and inquiries about coastal frequentation, I would say, over the coastal areas. Well, I guess I've made it. Not in the time I was thinking, but I've made it. So thanks again for following us today. And of course,
interesting. Thank you very much.
Yeah, if you have some questions, if you want to share questions right now or later, do not hesitate to come back to me.
You have a box to ask the question.
Yes, I have a couple of minutes, yes, to share some questions.
Yeah, maybe one first question about your customers. I assume it was local authorities, or do you have also private customers?
Yeah, you're right, Aurélie. Yes, most of our customers are public stakeholders. So all the environmental authorities dealing with the topics biodiversity, coastal areas, coastal monitoring. So frequently this can be authorities linked to the Ministry for Environment. It can be coastal cities. It can be, yes, all the people managing biodiversity at every levels, I would say. But yes, these are mainly public authorities and public stakeholders.
And with your analysis, are you also provided some advices to manage the coastal area?
Well, in the past, it was the case. I was looking if I normally you're not seeing anymore the presentation, but I was looking for the webcam. Sorry. It can happen, but finally, you know, all this stuff and all these products using satellite remote sensing are really providing added value and are very differentiating with what the more traditional companies in our field of expertise, coastal engineering companies and so on, are proposing. So yes, we can provide in some of these issues and some of these issues, we can provide some coastal expertise, for instance, about the sediment dynamics and so on, or about the way the coast is moving, coastal change, and the interpretation of the results. But it's less and less the case right now. We are more providing finally added value products derived from the satellite observations, and that's it. And we are also I can add the word that we're not doing all of this alone. We have some expertise and, well, quite detailed expertise about the coastal dynamics and so on. But we're working in partnership with colleagues, in particular when dealing with biodiversity. We do not have in IC the know-how and the expertise to get these ground truths over the field, this ecological expertise. And we are quite fan of working with people that are providing this complementary expertise to and provide more added value to the satellite products. And this is more the way we are working, providing information, providing new products for knowledge enhancement and decision support. And then the other guys, experts in each of their field of interest, then are taking the results and are working over these results and getting some synergy to provide new knowledge and provide the new knowledge that is necessary for feeding the support and decision support to the final stakeholders. This is more the way that is working right now.
Okay, that makes sense. And we have a question about your annual turnover. I don't know if you want to answer to this.
Who is asking that, Aurélie? Tell me.
I'm not allowed to tell it.
No, I'm making fun, but yes, IC is quite a small company still. 7 years after founding it, we are about 10 people right now. IC's turnover last year, 2020, was around 1.2 million euros per year. And we are definitely in a growth trend, and especially over the topics dealing with biodiversity, there's really a big adhesion of the final stakeholders to the satellite products. And we are investing commercially to develop our commercial activities, in particular over this field of biodiversity, but also about the other issues dealing with coastal monitoring. Yeah, you may know that this is really helpful, and I take the occasion also to thank maybe ISA that has been given us the opportunity to work at another scale than local scale. And also this growth of activity and of turnover, these 2-3 last years, is really linked also to the gain of European projects and European contracts with the European Space Agency. Just to give a word, the ESA Coastal Erosion Program IC is leading. This is 2 million euros of turnover crossing IC for 3 years of activity. So it gives an idea of how this kind of European contracts with some major governmental, being space or environmental agencies, can be really a booster for very small companies like IC.
Okay, I think that's all. So, thank you again for this webinar and for all this very interesting information, and good luck.
Yes, thanks Aurélie. We'll see soon, and we will be able soon to share this good luck physically, but yeah, to share some word with the ISABIC. Yes, I'm quite grateful to the guys and ISA, CNES, and so on, and Aerospace Valley, the supports you gave us and you're still giving this year's. It's going in the good direction, and it's all to some extent thanks to your support. Yes.
You're welcome. It's always a pleasure. Okay, so thank you very much.
Okay. Thanks for the invitation, and I will share with you the slides. So if you want to make them accessible to the audience, it's okay.
Okay, perfect. Thank you. And bye-bye. Good afternoon.
Yeah. Thank you, everyone. Bye-bye.
Bye-bye.